Hi everyone, today we're going to learn how to form a composite function. First of all, let's see what is a composite function. When we apply one function to the result of another function, this is called composing two functions. For example, here when we are washing and drying our clothes, we're actually composing two different functions. So we give our dirty shirt to a washer, and this is what we give to this function. Let's call that f, and then the result of this function, or the output, is a shirt which is clean but it's actually wet. Then the result of this function is going to be given to another function. Let's call this g, which is our dryer, and then the result of one function is going to be given to the dryer, and then this dryer is going to work on this input and give us the output, which is a dry and clean shirt. So the result of f was given to g here. So this is kind of composing function. This composition of function, if we call this one f and this one g, could be written as g of f of x. So here f of x was our washer, which we actually used first, and g of x is the dryer, which we used as the second function. So we can also use this notation as composite function. So this is g of f of x. Another example could be here. For example, we have g of x equal to x minus 3 and f of x equal to square root of x. Then I give 3 to g of x, so this is my input of g of x, and then give it to g of x, it gives us 0. And then I use this 0 as input of my second function, which is f of x. And then this is gonna take 0 and find the square root of that, which is 0. Another data that I'm going to give to this function could be, for example, 7. I give 7 to g of x and then takes 3 out of that 7, so give us 4, and then this 4 is going to be used as input of f of x. And then square root of 4 is equal to 2. So we use the output of one function as the input of another function. But we need to be careful about what we are giving to these two functions. For example, if I give 2 to g of x, it will turn it to -1, because 2 minus 3 is equal to -1. And then I am going to use this -1 as input of f of x. So this function, f of x, is trying to find the square root of -1, which there's no solution for this. We know that we can never take the square root of a negative number, so this one is not defined actually. So generally speaking, we can say whatever I give as the input of the second function, which is basically output of the other function, should actually fit in the domain of the second function. So output of first function should fit in the input of the second one, should fit in the domain of the second one. Otherwise we will have this kind of problem. For example, it's not defined. So let's go back to the notes that we had. Domain of f of g is the set of all the numbers x in the domain of f, such that g of x is in the domain of f. So this is exactly what we just talked about. We give an input to g, for example, the output is f of x. This output is, g of x. This g of x is actually range of g, which is going to be as input of f. But as I'm giving g of x as the input to f, this g of x must be in the domain of f. Otherwise, we won't have any defined output for that. So let's try some examples here. We want to find f of g of 1. Always, if I have f of g, I can write that as this notation, f of g of x. So basically this g of x is our washer, which should be done first, and then we go to the second one, which is f of x. That's our dryer. So it's always inside to the outside. The one which is inside is going to be applied first. So this value that you see here, 1, is our x. We're going to replace x with 1 here. So basically I need to find f of g of 1. As we just said, g of x is the washer, which should be done first. So we're gonna change this as g of x. Wherever I have x in my g of x, I'm gonna replace that with 1. So g of 1 is 4 times 1, which is 4. So I need to find f of 4 now. Now what is f of 4? We go to the f of x. Wherever we have x, we're going to replace that with 4. So this will be 2 times 2 squared minus 3, which will be 2 squared is 4 times 2, 6 minus 3 is 3. So this is the answer of this part. Okay, I had to make a correction. This was f of 4, so it's 2 times 4 squared minus 3, which is 29. Now we're going to work on the second part, g of f of 1. So I'm going to rewrite this as g of f of 1. First of all, let's find f of 1, because this is the first thing that we need to do. F of 1, we go to the f, and then wherever we have x, we're going to replace that with 1. So that's equal to, I'll just keep the outside function untouched. So f of 1 is 2 times 1 squared minus 3. This is 2 minus 3, which is negative 1. So I need to find g of negative 1 now, because 1 squared is 1 times 2 is 2 minus 3 is negative 1. Now what is g of negative 1? We go back to g of x. Wherever I have x, I'm going to replace that with negative 1. So this is 4 times negative 1, which is negative 4. Now let's go to the next part. This time we're composing f of x with itself. So I need to find f of negative 2 this time. So let's start with the inside one first. What is f of 2? First of all, let's keep the outside function untouched here. The inside one, f of negative 2 is 2 times negative 2 squared minus 3. So I just replace this negative 2 for x. Okay, so this is negative 2 squared, which is 4, times 2 is 6, minus 3 is 3. So inside parentheses was 3. So I'm going to replace that here, f of 3. This is what I need to find now. Now what is f of 3? It's 2 times, I just replace it with the x here in f of x. 2 times 3 squared minus 3. 3 squared is 9. 9 times 2 is 18. Minus 3 is 15. The last one, we are composing g with itself this time. So g of g of negative 1. So let's start with the inside one. We'll keep the outside one untouched. What if g of negative 1? So in g of x, we're going to replace x with this negative 1. So it's going to be 4 times negative 1, which is g of negative 4. This time, my new x is negative 4. So in our original g of x, we're going to replace negative 4 with this x. So this will be 4 times negative 4, which is negative 16. So this is our answer. In the next problem, we're trying to find composite equation of the composite function. So f of g of x, instead of finding the value, we're trying to find the equation. Again, we start with f of g of x. Outside one will be untouched. The inside was g of x. So whatever I had as g of x, we're going to replace that here. So this will be f of 4x. Now, this 4x is actually our new x. So in our original function of f of x, wherever we had x, we are going to replace that with this 4x. So we had 2 times actually x squared minus 3. This was our f of x. But instead of x this time, we are going to replace this 4x. So this will be our new value for x. So I'm going to replace that with 4x. Then I just need to simplify this a little bit. 4x squared is 16x squared. Times 2 will be 32x squared. 32x squared and minus 3. So this is our equation for f of g of x. Now we can start working on g of f of x. So here we need to find g of f of x. So I'm going to write with the other notation, g of f of x. So this is equal to g of, now whatever I had as f of x, I'm going to replace that here in parentheses. So instead of f of x, I'm going to write the equation, which is 2x squared minus 3. Now, this value that you see here, this is our new x for g. So in our function of g of x, I had 4 times x, which instead of that x, we are going to replace and write this value, which is 2x squared minus 3. So this is g of f. We can just simplify that. Distribute 4 here, it will be 8x squared and minus 12. So this is the function of g of f of. In part B, we have two other different functions, and we try to find f of g of x first. So again, f of g of x. Whatever I have for g of x, which is x squared, is going to replace here for g of x. So I'm going to keep the outside one untouched, and then inside, instead of g of x, we can replace x squared. Now let's go back to f of x. What did we have for f of x? It was 3 over x minus 4. So this x that we had here, we're going to replace that with this x squared. This is our new x actually. So I'm going to replace this x with the new value of x, which is x squared minus 4. So this will be the combination or composite function of f of g of x. Now let's find g of f of x here. So we start with writing the notation g of f of x. We keep the outside untouched. The inside function, which is f of x, is 3 over x minus 4. So we replace f of x with 3 over x minus 4. Now, what was g of x? G of x was x to the power of 2. So whatever I have in the parentheses here is going to be my new x. So instead of writing x to the power of 2, we're going to write 3x minus 4 to the power of 2, because this whole thing is now my new x. Okay, so this is the answer of g of f of x. Then we're going to find some values here. Evaluate g of f of 3 first. So g of f of 3 is going to be like this, g of f of 3. So we need to find, excuse me, I made a mess here. Okay. So we need to find the inside first, because it's always starting from inside, then goes to the outside. So what is f of 3? Here in f of x, we're going to replace 3 for x. So this will be g of f of 3, which is 3 over 3 minus 4. 3 minus 4 is negative 1. And 3 divided by negative 1 is negative 3. So inside parentheses is actually equal to negative 3. Now we need to find g of negative 3. What is g of negative 3? G of x is x to the power of 2. So here, for x, we're going to replace negative 3. It will be negative 3 to the power of 2, which is equal to 9. So this is the value of g of f of x. Let's go to the next one. F of g of x. F of g of 3. So we're going to go from inside to the outside. It means we do g of 3 first. So I'm going to keep f outside. G of 3 is 3 to the power of 2, because this 3 is going to replace x. So 3 to the power of 2, which is 9. Now this 9 is my x for f of x. So f of x was 3 over x minus 4, which my x now is 9. So this will be 3 over 5. The next problem is g of f of 2. So we start with the inside one. F of 2, we need to find it first. So keep the g outside. F of 2 is 3 over 2 minus 4. And what is 3 over 2 minus 4? Is 3 over negative 2. So this is equal to g of 3 over negative 2. So this is my new x for g now. What was g? G was x to the power of 2. So whatever I had for x, I'm going to raise that to the power of 2, which is equal to 9 over 4. The last problem is f of g of 2. So let's try this one. F of g of 2. Keep the outside one untouched because it's inside to the outside. Always the inside is the washer, which will be done first. So g of 2 is going to be 2 squared, which is equal to 4. So this is f of 4. Now we need to find f of 4. Let's go back to f of x. It's 3 over x minus 4. So this will be 3 over 4 minus 4, which is 0. 3 over 0. And we know that anything divided by 0 is actually undefined. The reason that we got undefined here was that the number that actually the input that we gave to the f, which was basically output of g of 2, was not defined for f. Because if you go back to the f of x, 3 over x minus 1, the function of the graph of this function is something like this. The rational function, which is moved 4 to the right. So the vertical asymptote will be moved to the right, and we also have a horizontal asymptote like this. And then the graph will look like this because it is actually vertically stretched. And we cannot easily actually see that, but it's going to be something like this. So the domain of this function is all the real numbers except 0, negative infinity to 0 and 0 to infinity. Because it's not 0. Let me fix it. It's not 0 because we have moved it 4 to the right, so it's negative infinity to 4 and 4 to infinity. This point is x equal to 4 because it has been moved 4 to the right. So it's all real numbers actually except 4. This is domain of f. Okay, now here I was doing f of g of 2, and we figured out that g of 2 is equal to 4. Now we're giving 4 to f as an input, but f is like I can accept anything except 4 because this is not in my domain. If you give it to me, I don't have anything to give you back. I'm undefined for f of 4. So this is what we actually talked about here. We said the output of g of x, which is going to be input of f, must be in domain of f. But here, the output of g was not in domain of f. So that's why we got undefined. So this was today's lesson. Hope it was helpful for you all. Practice more to learn more. Have a great day.